So I'm not a big fan of tables. I know textbooks do it, but in real life, when we have a problem that we're trying to solve, we're not given the information to us in a table. We're given information to us like this. So either way works. I'm going to do exactly what the table is going to do to solve this problem. A 20% solution of fertilizer is mixed with 70% in order to get 100 gallons of a 60% solution. So if you think about it, that must mean there's more of the 70% than the 20%, right? Because when you mix them together, you got a 60% solution. So we know we're pouring two different solutions together, more of the 70%, but we don't know exactly how much more until we do some mathematics. It says how many gallons of the 20 and the 70% solution should be mixed. So there's two things we don't know. That's why the table has an X and Y. There's an X amount of 20% fertilizer, and there's a Y amount, or whatever letter you want, of the 70% fertilizer. Okay? So I'll let X be the 20%, and Y is the amount of 70%. So we have something right off the bat. X gallons plus Y gallons needs to be 100 gallons, right? The amount of the 20% solution plus the amount of the 70% solution, they said they wanted a 100-gallon solution. But when there's two variables, you can't solve with just one equation. We need two equations. Okay, so the next equation we're going to make is based off the percentages. 20% of the first type of solution plus 70% of the other type of solution would equal 60% of the final solution, 100 gallons in that final solution. Okay, so this is the amount. The percentage of fertilizer from the first one. The amount of fertilizer. Sorry, I should say the amount of fertilizer from the first one plus the amount of fertilizer from the second one equals the amount of fertilizer in the final mixture. Now we have two equations, so that's something we can solve. So with systems of equations, when you have your x's going first and your y's coming second, that lends itself to something called the elimination method. I'm retyping to make it a little easier on the eyes. I'm trying to line up my x's and my y's. And here, 0.6 times 100, that's not going to be a variable. We can just calculate that right now. So one thing you can do is you can manipulate either of these equations so that if you were to add the two equations together, it would make a letter cancel out. Okay? So one thing that the textbook does is that they multiply the top by negative 0.20. And the reason is because negative 0.20 times x, that's going to add to the bottom when we smush these equations together. It's going to cancel out. But if I multiply x by negative 0.20, I got to multiply everything else by negative 0.20 to keep the equation balanced. X times negative 0.20 looks like this. Y times negative 0.20 looks like this. 100 times negative 0.20 looks like this. And we're going to copy down the other equation because we haven't changed that at all. Okay, so now if we add the top equation to the bottom equation, the x's are going to disappear because negative 0.2 plus 0.2 makes 0. Okay. And then negative 0.20y plus 0.70y makes 0.50y. And then negative 20 plus 60 equals 40. And the last step, this is 0.5 times y equals 40. We want to divide 0.5 from both sides. So with my calculator, I'm going to do 40 divided by 0.5. There, we know there's 80 gallons of that 70% solution, so 20 gallons of the other one. We've solved the problem. Okay, and so a question I've received from a student is, where did that negative 0.20 come from? That was a number we picked. There's other ways of doing this problem. That was just a number we chose so that when we add the two equations together, it would make something cancel out. Here's another way of doing this problem. You're going to get the same answer. I multiplied the top by negative 0.70. Keep the bottom the same again. Because now, if I add these two equations together, y's are going to cancel out. Now, if I divide negative 0.5 from both sides, I get x is 20, which is the exact answer that we got when we solved the problem with the other method. So where did the negative 0.20 come from? It was the number we chose to make the letters cancel out when we added the two equations.